Now, Pearson's correlation coefficient is an index of the extent to which two x and y variables that are measured on a continuous scale relate to each other. So this is the correlation coefficient that we can describe in terms of magnitude, which gives us an indication of the strength of the relationship, as well as valence, which gives us an indication of the direction of the relationship. And we compute the correlation coefficient with the product of the x and y deviations from their respective means. Now, this procedure is detailed in a step-by-step fashion in section 10.5.1. I wanted to take you through kind of the elements of the equation. This looks like a very scary equation, but it isn't. This refers to the general idea that we have a cross product term. Okay, so here is our deviation term that we're multiplying together, and we're subtracting this by the result of taking however many people we have in our sample times the mean of x times the mean of y. And so that's our numerator of this equation. And then the bottom involves us summing and squaring x and subtracting the product of our sample size times the mean of x squared. Likewise, here I have the sum of the y squared values minus, again, the product of the sample size multiplied by the mean of y squared. And I take the denominator, this entire denominator, I take the square root of that value. So again, if we look at this equation just as one piece, it's very confusing. But section 10.5.1 goes through this in detail on exactly how to come up with the correlations. And so you're going to need to do this for both problems on your homework assignment for this week. Have some practice with that within Revel before you attempt the homework assignments. Now, once I have the R coefficient, I want to test it for statistical significance, testing the null hypothesis that no correlation exists in the population. So the population parameter that's estimated by R is called rho, the Greek letter rho, or RHO. And it tests the hypothesis that there is no correlation coefficient. And this is tested with the t ratio with 2 degrees of freedom, when n minus 2 is our degrees of freedom, n is the number of pairs. Now this is detailed in section 10.5.2, but essentially we can, if we have R, we can solve for the t ratio by multiplying R by the square root of n minus 2 and then dividing it by 1 minus R squared. Okay, so these are very knowable and doable and masterful equations. They're not ridiculously complicated, even if you're not used to working with formulas. I promise you it's a step-by-step process. Just look through 10.5.1 and 10.5.2 for help going through these calculations. If you can go through this equation to solve for R, and if you can test the significance of the correlation, you have what you need in order to do the first homework assignment for this module.